Okay, let's answer the following questions. Number one, which of the following is true when the percent yield is equal to 100%? Again, the percent yield is equal to the theoretical yield over the actual yield, and of course times 100. So obviously, for the percent yield to become 100%, the theoretical yield must be equal to the actual yield. So the answer for number one is letter B. The actual yield is equal to the theoretical yield. Number two, in the reaction of N2 plus TH2, what is the mole ratio or the molar ratio of N2 nitrogen gas to ammonia NH3? So the ratio can be observed on the coefficients on the balanced chemical equation. Again, the coefficients are the number before the different formulas in this equation. So here again, for nitrogen gas, that is 1, and then for ammonia, that is 2. So the ratio here is 1 to 2. For every 1 N2, we have 2 NH3. So the ratio here is letter B, 1 to 2. Next, number 3. For number 3, we have what is or which of the following are the products of the reaction of methane and oxygen gas? So methane, this one is a hydrocarbon. So a hydrocarbon, from its name, this is composed of a hydrogen bonded to a carbon. And here, this one is reacting in the presence of oxygen gas. And this one is a combustion reaction. Again, combustion reaction. So here, this methane is burning in the presence of oxygen gas. So again, that's when a hydrocarbon, it's any hydrocarbon, whether it's methane or we have C2H2 or this one is ethane. Again, when a hydrocarbon reacts with oxygen gas, this one is a combustion reaction. And again, for a combustion reaction, the products are always carbon dioxide and then water. So the answer for number 3 is letter C, carbon dioxide and water. Number 4, for the reaction of 4A plus 6B yields 2C plus 3D, how many moles of D are produced from 16 moles of A and 18 moles of B? So here again we have two products, 16 moles of A and then 18 moles of B. Again, let's determine how many moles of D can be produced from this amounts of the reactants. We have 16 moles of A. Again, let's calculate how many moles of D can be produced from this one. Again, from moles of A to the moles of D. And again, this one is our molar ratio. The molar ratio depends on the coefficients on the balanced chemical equation. Again, for every 4 moles of A, we have 3 moles of D. And if we solve this one, we have 12 moles of D. How about for the B? We have 18 moles of B. 18 moles of B. This one is 3 rather. The same thing for from the moles of B, let's determine how many moles of D can be produced from this one. Again, we have for every 6 moles of B, we have 3 moles of D, and if you solve this one, we have 9 moles of D. So over here, we have 16 moles of A can produce 12 moles of D, but 18 moles of B can only produce 9 mole of D. So again, this one is our limiting reactant, and this limits the final amount of the product. So here, only 9 moles of D can be produced from the reaction. So for number 4, the answer is letter B, 9 moles of D. Number 5, which of the following is true in the reaction A plus B yields C plus D if the quantity of B is insufficient to react with all of A? So it's obvious from the definition here. Again, for every, or B is insufficient to react with all of A. So obviously B is the limiting reagent or the limiting reactant.